Good morning, class. I'm here today to speak with you in regards to complex numbers. I just want to say thank you very much for actually joining, or enrolling, I should say, into Math 101, Section 5, College Algebra. So before we even jump into complex numbers, I would just encourage you to kind of go over the Section 3 revision part of Section 3, because that would typically give you a good overview as we move into working in this section. Okay. Again, please go over R3. I have a video uploaded dealing with section R3. Okay. Um, and complex numbers will be on your quiz. Okay. Complex numbers will be on your quiz. So as we move forward, we want to be able to simplify the powers, what we call I. Okay. Now, before I go into I, which is the complex number, let us consider determining the solution of this expression right here. Okay, x squared minus 1 equals 0. So in doing so, we can take the negative 1 to the other side of the equation. Therefore, it's going to be x squared equals 1. And then we can take the square root of both sides, right? And then when we solve, we're going to get x equals plus and minus 1. Okay? Meaning that x can be a positive 1 or x can be a negative 1. So either one of these solutions should be a real solution. But let's check it. And how do we check it? We take either value or both values and we plug it back into the original equation. So for instance, x equals plus 1, right? We plug that back into x squared minus 1 equals 0, as you can see here. And then we're going to get 1 minus 1, which is going to be equals 0. So 0 equals 0, that's a real solution. Now if x happens to be negative 1, we do the same thing. 1 minus 1 equals 0, 0 equals 0. So it proves to us that this x, which has a plus and minus negative 1, is a real solution. Okay? And again, what determines a real solution? If the value on the right hand side is equal to the value on the left hand side of the equation. Okay? In this case, it's going to be 0 equals 0. Okay. Now, let us consider if our expression happens to be x squared plus 1. Okay, we do the same thing. We take the plus 1 to the negative side of the equation. Now it turns into a negative 1. Okay, so that's x squared equals negative 1. Now we want to take the square root of both sides. Okay, now we get x equals the square root of negative 1. So this negative 1 is what we call an imaginary number, and it's denoted by I, or represented by I. Okay. Now, our I, since we know it to be square root of negative 1, if you square it, if you square that I, you're going to get the square root of the square root of negative 1, which happens to be negative 1. Okay. If you raise the power to the third, you could just break its components down into I squared times I. Okay. So remember that I to the third equals I squared times I to the 1. Since the bases are the same, you can add the exponents. Okay. And if you add the exponents, 2 plus 1, it gives us 3. Okay. So likewise, you can do the same thing for I to the 4. Okay. I squared times I squared would be negative 1. Since I squared is negative 1, so that would be negative 1 times negative 1, which is just a 1, a positive 1. Okay. I to the 5th, you can break that down into I to the 4th times I, or you can break it down to I to the 3rd times I squared. Either one will give you the same answer. Okay. Likewise, I to the 6th, you can break it down this way. Since we already know what I to the 4 is, right? I to the 4 is here. You can just plug that number in, which is a 1. 1 times I squared is what? Negative 1. It's negative 1. So 1 times negative 1 gives us a negative 1. Okay? So you can do that for I to the 7 and I to the 8 and so on and so forth. Okay? So let's take an example. I to the 43. Okay? It seems like a very large number, but we can break it down. Okay? 43, we can say I to the 3, right? And then I to the 4 10 times, right? I to the 4 10 times. Okay? So I to the 4 10 times will give us 40, right? Because we can actually add exponents. Okay? So 4 plus 4 plus 4 plus 4 10 times, of course, will give us 40. Then plus the 3 here gives us 43. So we already know what I to the 4 is, right? I to the 4 is 1. So that gives us negative I, because I to the third is negative I, and then I to the fourth is 1. And if you take that, raise that to the power 10, of course, that's just going to give us negative I. Okay? So I to the 43 happens to be negative I. Okay? I to the 100, same thing. We can break this down. We already know that I to the 4 10 times, which is 40, right, is just 1. Okay? So we take the same principle and we can break it down and say I to the 4th 25 times. And we already know what I to the 4th is. I to the 4th is 1. So 1 raised to the power 25 is nothing more than just 1. So I to the 100 is equal to 1. That's your answer. Okay. Now this is slightly different. I to the negative 1, I to the negative 21. We can rewrite it in a positive sense. This is a positive notation here. Okay, so keep that in mind. That's a positive notation. This is the negative notation. Okay, so when we change to our positive notation, we can break it up as we did in the denominator here. And then we can go through the same process as we did in the previous examples. I to the 4th 5 times is nothing more than just 1. Okay, 1 raised to the power 5 is 1 times the I gives us the I. But since I is in the denominator, we have to multiply it by I over I. So we get 1 over I times I over I. Okay, we know that I times I in the denominator is I squared, which is negative 1. And then 1 times I is nothing more than I. So now in this case, our answer is negative I, okay, which we have here. Okay. Now the second objective they want to move into is how do we add and subtract complex numbers. Okay, so kind of keep in mind that you're adding and subtracting the real part of the expression, and you're adding and subtracting the complex numbers together. So you don't mix the two up. So within a complex number, you have what you know as the real number, and you have the complex number. So as I have here, a plus bi, this is the form. The a is the real number, and the bi is a complex number. Okay? So for instance, you have this expression here. You want to add these two expressions up. Again, the 7 without the I is a real number, and the 5i is a complex number. Okay. So in this case, we're just adding the real numbers together and the complex numbers. So 7 minus 2. We open up the parentheses, then we have negative 5 plus I, which is right here. So our answer is 5 minus 4i. Okay. And this is what you know as the standard form. Okay. Now, what if you want to subtract the two? Okay. Same expression, but now we're subtracting. In this case, we were adding. Now, in this case, we want to subtract them. Okay. So likewise, the same thing. You bring the real terms together, 7 minus 2, and then once you open up your parentheses, It'll be a negative times this negative, which gives us a positive. Negative times this positive gives us a negative. Okay, so kind of keep that in mind when you open up your parentheses. There's going to be a change in your signs. And you're going to get 7 minus 6i. Okay, and this is our answer. Okay. Objective 3. Here we want to be able to multiply complex numbers. Okay, and just keep in mind that this is your base. I squared equals -1. Okay. Now, if they want us to simplify this, 4 minus 3i times 7 plus 5i, we're going to implement FOIL. Okay, so we have our first expression. This is our first step. Then this is our second step. This is our third step, and this is our fourth step. So 4 times 7 is 28. Okay, then 4 times 5i is plus 20i. Then negative 3i times 7 is negative 21. And then negative 3i times plus 5i gives us minus 15i squared. Okay, and when you do the math, we know here that 20i minus 21i gives us a negative I, and we know that this I squared happens to be a -1. Okay, so this is where we get the -1 from. Okay, so 15 times -1, negative 15 times -1 gives us a positive 15. Okay, so we add the real numbers, which is 28 and 15, which gives us 43 minus I, and this is our answer here. So in a complex conjugate formation, this process just tells us that we're going to, if they're giving you an expression and they want you to multiply this expression by its conjugate. The conjugate is nothing more than instead of having a plus sign here, you're going to have a negative sign here. So that's what the complex conjugate means. Okay, so in this case, multiply the complex conjugate of -2 minus 7i. So when you do that, this is -2 minus 7i. Its complex conjugate is going to be -2 plus 7i. Okay, please keep that distinction in mind. It's very important. This will be on your test as well and as your quiz. Okay, so when we have this formation here, we can do the same process as we did earlier using FOIL. Okay, and when you do that, you're typically going to get 4 plus 49, which is 53. Okay. Okay, so let's see how we can change colors here. Okay, so our objective 4, we want to be able to simplify the quotient of complex numbers. So we just did adding and subtracting. Now we want to do the quotient of complex numbers. Okay, so keep in mind that you're really you're going to multiply this whole expression by the complex conjugate of your denominator. Okay. So it shows this in this example here. We have 1 minus 3i divided by 5 minus 2i, and the complex conjugate, which you're going to multiply this expression by, is this: 5 plus 2i divided by 5 plus 2i. Okay, and when you do that, you can actually do the FOIL again. You can perform the FOIL operation. So you get 1 times 5 is here, and 1 times 2i is 2i, and then you're going to have -3 times 5, negative 3i times 5, which gives us negative 15i. Negative 3i times the positive 2i gives us a negative 6i squared. Okay, and likewise you do for the denominator as well. Okay, and then when you finish your expression, you're going to get 11 minus 3i divided by 29. But don't stop here. This 29 belongs to the 11 and the 3i, so which you can see here is being broken up. So this is your real number, and and this is your complex number. Okay, and keep in mind they may ask you, they want it, they in the exam or in the quiz, they want the answer in the a plus bi form. Okay, a meaning your real number and the bi meaning your complex number. Okay, just keep that in mind. Okay, so as we're wrapping up with objective 6, we want to be able to simplify um, radicals with a negative radicand. Okay, and in this case, again, this plays a role. The I equals the square root of -1. Just like if I were to square both sides, equals -1. I'm sorry, -1 squared. That's I squared equals -1. Okay, so there's a relationship between I equals the square root of -1 and I squared equals -1. Okay, so keep that in mind. So whenever we want to simplify this expression here, the square root of -108, we can take out the square root of -1, which is just, you just multiplying it by the square root of 108, and then you can simplify it. The square root of 108, which is nothing more than 36 times 3, and the square root of 36 is nothing more than 6. So this is I times 6 times 3, square root of 3, and now we're going to get 6I root 3 as your answer. Okay, I hope this helps. I'm going to stop here, and then I'll continue with some more example problems. Thank you very much.